And now to example 1. Okay, first example. So over here we have a right angle triangle ABC. Okay, so AB is 6 cm, AC is 13 cm. So now the question is, how do you find angle ACB? I shall use the red color pen to denote the red color marker to mark out where's ACB. Let's take a look. ACB. Right? So ACB means I'm trying to find what is this angle C. What's angle ACB? So over here, some of you will say, Mr. When I see right angle triangle, I think of Pythagoras theorem. Can you use Pythagoras theorem to solve for an angle? The answer is no, cannot. Okay? Because Pythagoras is only useful, Pythagoras theorem is only useful to find the length of a right angle triangle if you have the length of the other two sides. Okay, you have two known sides of a right angle triangle, then you can use Pythagoras theorem to find the third unknown side. Pythagoras theorem cannot be used to find angles, cannot. Okay, so in this case, since it's a right angle triangle, we can think of using Trigo ratio. Okay, how do we do it? Okay, so let's run through the critical question, the 3 critical questions that I shared with you in the last session. Okay, on how to use Trigo ratio to find length. Today's lesson is using Trigo ratios to find angles. What's the difference? Only one difference only, okay? Please take note. Over here, I need to ask myself the first critical question. What do I have? What do I have? Let's take a look. I have... Oh, sorry. Before I do that, I must first label the triangle. I nearly forgot. Always label the triangle first, okay? Always label hypo, followed by opposite, followed by adjacent. So let's take a look. We label this triangle first. Label the hypo first. So AC is the hypo. So if this is my reference angle, right? If angle ACB is what I'm interested in and look opposite it, so this must be my opposite. And then last but not least, this is the adjacent. Okay, double check. Adjacent is the line that touches both the right angle and the reference angle. Alright? So now I ask myself, what do I have and what am I trying to find? So critical question, first number 1. What do I have? So what do I have? Let me try to find. I have the hypo. Put the tick there first. Okay, I have the hypo. What else do I have? I also have the opposite 6 cm. So put a tick here. So for this question, you have the hypo and you have the opposite, right? You don't have adjacent. So you tick out what you have first. What do you have? Tick first. I have hypo, I have opposite. Next critical question asks you, what are you trying to find? I'm trying to find angle, right? I'm trying to find the angle over here. So third question asks you, which Trigo ratio ties them up? So hypo, opposite, you're trying to find angle. Which Trigo ratio ties them up? Which Trigo ratio ties up hypo and opposite? Let's take a look. Opposite and hypo. Which Trigo ratio? Opposite and adjacent? Adjacent and hypo. There you go. You have this one. Opposite, hypo, right? Opposite and hypo. So you know for this question, you need to use sine, right? You need to use the Trigo function sine to find the angle, the size of angle ACB. So sine angle ACB is equals to opposite over hypo. Opposite 6, hypo 13. There you go. Okay, so one more step only. So to find angle, right, the one thing that is different from finding length is you need to press a special button. Okay, once you press the button, it allows you to find the angle already. Okay, so how do you get rid of the sine function? Over here I introduce this to you. This is called the sine inverse. Okay, the inverse. Okay, sine inverse, shift sine, then 6 over 13. Where to find this button, Mr. Where to find? Very simple. Okay, on your calculator, if you look at your sine button, right, your sine button, on top of it, you'll notice there is this sine inverse, sine to the power of -1. Okay, likewise, you look at cosine. Cosine also will have, on top of it, you have cosine to the power of -1, right, cosine inverse. And then tangent will also have the same thing, tangent. So you have, on top of it is tangent to the power of -1. So to punch this, right, all you need to do is punch, instead of normally you just punch sine of an angle, right? So to find angle, you must punch shift sine first. So punch your inverse button, then punch sine. So in this case, I want sine, right? Press sine, then you can press bracket 6 over 13. So you punch 6 over 13. Okay, you can press 6 divided by 13 also can. Then after that, Mr. Where's my answer? Of course you don't have the answer because you haven't punched equal ma. Punch equal. There you go. Once you punch the calculator, punch equal sign, the answer come out. Okay. So in this case, we have 27.486. 27.486. Okay. So if it's an angle, do you round off to 3SF or 1 dp? 1 dp, right? So round to 1 dp. So 27.5 degrees. 1 dp. Okay, 1 dp. Is this okay? Cool. Okay, I move on to second example over here. Second example, same thing. I'm going to go through the same 3 critical questions. Ask myself, what do I have? Second point, what am I trying to find? Number 3, which Trigo ratio ties them up? Alright, let's take a look at this. This is a triangle, PQR. PQ is 10 millimeters. QR is 15 millimeters. I want you to find angle PRQ. So angle PRQ, let's take a look. Angle PRQ means you want to find this angle, right? So always remember from the start, label the triangle first. Let's label the triangle. Okay, so we label first. So in this case, always label the hypo first. So this is the hypo. How do you know, Mr. Ng? It's the length that's opposite the 90 degree. Right? It's also the length that's longest of a right angle triangle. Next, label the opposite. So if this is my reference angle, look opposite it. So PQ is my opposite. Last but not least, this must be my adjacent. Double check. Adjacent is line that the 90 degree and the reference angle touches, sits on it. Okay? Okay, so now I ask myself the critical question. Number 1, what do I have? What do I have? Let's take a look. Do I have hypo? I don't have. What else? What do I have? I have opposite. Mr. Ng, I have opposite. Very good. What else do I have? I also have adjacent. Put the tick there. So you have opposite, you have adjacent. Next, ask yourself, what am I trying to find? You're trying to find angle, right? Trying to find angle. Third important question, which Trigo ratio ties them up? Which Trigo ratio ties up opposite and adjacent? Let's take a look, okay? Let's take a look now. Which one? So, opposite, adjacent. Ah, this one must be this one, right? Because this is the only one that ties up opposite and adjacent. Let's take a look at this. This one ties up, the cosine ties up the adjacent and the hypo. The sine ties up the opposite and the hypo. So only the tangent ties up the opposite and the adjacent. So this one, we are using tangent to find, right? Tangent, angle PRQ. Remember, tangent is little t, huh? Tangent equals opposite over adjacent. So opposite, what's my opposite? My opposite is 10. So I write 10. What's my adjacent? Adjacent is 15. Okay, if you want to, you can simplify this. Divide by 5, this is 2. Divide by 5, this is 3. Therefore, angle PRQ is equals to tangent inverse. So you can write 2 over 3 here. But if let's say some of you are not very confident, Mr. What if I don't know how to simplify this? Don't worry, then don't write 2 over 3. Just simply tangent inverse 10 over 15. Let the calculator do all the work for you. Okay? So how do you punch this? Okay, look at your calculator. You see where tangent is? You don't want tangent, you want shift tangent. You want the tangent inverse, right? What's on top? So punch the inverse button. Okay, the shift button on the inverse button, and press tangent, bracket. So 10 over 15. So 10 over 15. Close bracket. There you go. Round off the answer. So this is 33.7 degrees. Okay, so 1 dp. Always remember angles round off to 1 dp. Angles round to 1 dp. Length is 3 sf. Okay, so since you're finding angles, every answer round to 1 decimal place. Okay, so you realize that for the lesson today, right, the only difference is when you want to find the angles, you have to punch the shift of a Trigo function, either shift sine, shift cosine, or shift tangent. Okay, I'll give you 2 more examples to help you better understand what this is all about.